Now, if we graph y equals x squared, we are familiar with the graph. Now it looks like this. Is this the graph of a function? Well, yeah, and we can see that from the graph. If I pick any value of x, any point along the x-axis, let's say this point, I can give you the corresponding value of y from the graph, to the extent that I can read the graph accurately. Okay, so if this is the value of x, I go up to here and over to here, and right there is my value of y equals f of x. And there's only one such value, so this is a function. Any x we choose, we draw a vertical line up to the graph and then a horizontal line over to the y-axis. We get the y value, and that y value is unique to that point x. There's only one y value for any x. And that's going to be the property as long as any vertical line that we draw corresponding to some x value, some value on the x-axis, intersects the line at only one point. If it intersects at only one point, then there's only one answer to what the value of y is for that particular value of x. By contrast, there's a graph that is clearly the graph of, or there's an equation that's clearly the graph of a circle. And any circle has the property that if you choose an x value in the domain of that function, that is an x value that gives you something for y, that except in two special cases, you're going to get two things for y. Okay? If x is this, then you get a y here, but you also get a y here. And then the question is, which y value are you going to choose? Which y value is the value of the purported function? Well, since the answer is ambiguous, this is not a graph of a function. Now there are 2 points. The point at the extreme here, if we take the x value that corresponds to the point, and we could define that as the point at which a vertical line is tangent to the circle on this side, then we get just a single y value, the y value at the point of tangency. And the same thing on this side, at the point of tangency, we get a single y value. But otherwise, we get two y values. Now, of course, there are plenty of x values that aren't in the domain of this relation, and it is a relation as opposed to a function, but it's certainly not a function, unless we restrict ourselves to these two x values. The domain is just the x value here that gives you the tangent point, and the x value here that gives you the tangent point. Then it would be a function. But if you include the x values between here and here, no, it's not a function. Now, also we have the graph of y equals x cubed. Well, that graph, as we know, looks like this. And again, any x value that we choose, there's only one point where a vertical line from that x value intersects the graph, and that is the value of y for the function. So we have this thing called the vertical line test. If a vertical line intercepts the graph in only one point at any point in the domain, then you have a function. Otherwise, as in this case, if the domain includes the points between here and here, you don't have a function. Also, not particularly relevant to these examples, if there is just one x value that gives you an ambiguous answer that intersects the graph in 2 points, that's enough. The function is, the graph does not display a function. The relation defined by that graph is not a function.